Hello everyone, how are you all? Hope all of you are well. I, S. Kumar sir, today I am going to start class 12 chemistry. P block elements. Before going towards P block elements, let me introduce about any block elements. What is S block, P block, D block or F block elements? If we talk about any block elements, then we must understand about the concept of atomic orbitals, that are S, P, D and F. Any elements whose last electron enters into S orbital is called S block elements. Any elements whose last electron enters into P orbital is called P block elements. Any elements whose last electron enters into D orbital is called D block elements, and any elements whose last electron enters into F orbital is called F block elements. Now, before starting this chapter, let me introduce about what is orbital. You know very well about the atom, the smallest particle of a matter which cannot be cut down, break down, which does not exist in the free state and can't be seen by the naked eyes is called atom. This theory was specially given by John Dalton. That's why it's known as Dalton atomic theory. But further, when the subatomic particles were discovered like electron, proton and neutron, then the smallest subatomic particles were there instead of atom. So now question is, in an atom, what is the probability of finding an electron? Where we can find an electron? So the maximum probability of finding an electron in an orbit is called orbital. So let me tell you first of all, if I am talking about this atom, just suppose this is an atom. Inside the atom, this is a nucleus where protons and neutrons are present. If we talk about the shells of the atom, KLMN or 1, 2, 3, 4 energy levels. Just suppose here this is the first energy level, this is second, third, fourth, fifth, sixth, so on. Now in the first orbit, how many electrons? As well you know, 2n square, where n is equal to number of orbit or principal quantum number, where we can see in the first orbit how many electrons are there. So we know very well the number of electrons in any orbit is equal to 2n square. This was given by Niels Bohr, which you have studied in standard 9. So if I talk about in the first orbit, then the number of electrons is equal to 2 into 1 square, that is equal to 2. So in the first orbit there are 2 electrons. Now in the second orbit, 2 into 2 square, that is equal to 8. So here you have seen that in any orbit the number of electrons. Now question is, electron is negative charge particle. What is this orbit and what is this orbital? Now let me clear you about the orbit and orbital. This whole is called an atom. In the atom, orbit or orbits are there. Now you can see this is the first orbit, second orbit, third orbit, fourth orbit. Now question is about, in this orbit, what is orbit? The path of electrons which revolves around the nucleus is called orbit. Orbit, energy level or energy cell, energy level or energy cell, or principal quantum number, right? So here this orbit is also known as these things: energy level, energy cell, principal quantum number. If anybody will ask you what is the define of orbit, then you have to just say that the path of electron the path of electron which revolves around the nucleus, which revolves around the nucleus is called orbit. Is called orbit. Now question is about this electron. Do electron stay at one position? Means is electron static? No, my dear student, electron is never static. Electron is always in motion, always in kinetic energy. So now question is, electron revolves around the nucleus. Here it's already written, it revolves around the nucleus, right? It revolves around the nucleus, and that path is called orbit. So now question is, how do we understand where is the accurate location of electron? Now question is about orbital or orbital, whatever you say. Orbital or orbital is just in pronunciation. Do not judge by this pronunciation that what is orbital or what is orbital. So now question is about the orbital. What is orbital? The maximum probability of finding an electron in an orbit is called orbital. So what is orbital? The maximum probability of finding an electron in an orbit is called orbital. So the maximum probability of finding an electron in an orbit is called orbital. So now how many types of orbital? There are total 4 types of orbitals. Which orbital? S orbital, p orbital, d orbital and f orbital. S orbital maximum number of electrons. Maximum number of electrons in this orbital is 2 in S, 6 in P, 10 in D and 14 in F. Right? So here I was talking about p block elements. Now question is, what are these p block elements? The elements whose last electron enters into p orbital is called p block elements. Is called p block elements. Is it okay? What is p block element? The elements whose last electron enters into p orbital is called p block elements. Now question is, sir, we have understood the concept of atom, orbit, orbitals, nucleus, principal quantum number and the types of orbitals. We have also understand how many electrons are present in these orbits, like in the first orbit 2 electrons, second orbit 8 electrons. We have understood this concept. Now question is about what is p block elements. Let's come to the topic. These are the basic concepts which we should understand before starting the chapter. The elements whose last electron enters into p orbital is called p block elements. It is located at the right side of the periodic table. P orbital has 3 orientations. Px, Py and Pz. And each orientation can maximum accommodate two electrons. So p orbital can accommodate 6 electrons. Therefore, it has 6 groups. Therefore, it has 6 groups, which starts from group number 13 and ends at group number 18. Is it okay? So this you can see here about the p block elements. What is p block elements? What is p orbital? How many electrons can maximum we accommodate in p orbital, and how many groups are there in p block elements? So here I have written a concept that why p block has total 6 group, what are the reason behind that, and where they are located. So now let's start about the p block elements groups name, how many elements are present in their groups. As I have written here that it starts from group number 13 and ends at group number 18. So let me first tell you about the names of this group number 13 to group number 18. Here I am just drawing a p block elements. Group number and period number. Group number 13, 14, 15, 16, 17, 18. Period number 1, 2, 3, 4, 5, 6, 7. Group number 13, boron, aluminium, gallium, indium, thallium, nihonium. Group number 14, carbon, silicon, germanium, tin, lead, flavorium. Nitrogen, phosphorus, arsenic, antimony, bismuth, meconium. Oxygen, sulfur, selenium, tellurium, polonium, livonium. Fluorine, chlorine, bromine, iodine, astatine, sodium. Helium, neon, argon, krypton, xenon, radium, oxynium. So these are the elements of p block elements of each group. Group number 13, group number 14, group number 15, group number 16, group number 17, and group number 18. So this is your p block elements, which is located at the rightmost side of periodic table. Is it okay? These are the group numbers: 13th group elements, 14th group elements, 15th group elements, 16th, 17th, and 18th. 13th group elements and 14th group elements, these two we have studied in 11th standard. And in 12th standard we will discuss from group number 15 to group number 18. From here, these both are of 11th standard syllabus. And from group number 15 to group number 18 is of 12th standard syllabus. Right? But let me tell you about the little bit concept. The general electronic configuration of p block elements. General electronic configuration of all the groups I am saying you, not only one group, that is NS2 NP126, means group number 13 NS2 NP1, Group number 14 NS2NP2. Group number 15 NS2NP3. Group number 16 NS2NP4. Group number 17 NS2NP5. And group number 18 NS2NP6. This is the general electronic configuration of all the p block elements. If you want to write the atomic number, then let me tell you about a magic number for p block elements. 288, 18, 18, 32. 288, 18, 18, 32, 32. The atomic number of boron is 5. So in the first period you have to leave. 5 plus 8, 13. 13 plus 18, 31. 31 plus 18, 49. 49 plus 32, 81. 81 plus 32, 113. If you know this only group number 13th element's atomic number, so you can now write it till the all elements. Carbon 6, nitrogen 7, oxygen 8, 9, 10, and the atomic number of helium is 2. So now 13 of aluminium, 14 silicon, 15 phosphorus, 16 sulfur, 17 chlorine, 18 argon, 31 gallium, 32 germanium, 33 arsenic, 34 selenium, 35 bromine, 36 krypton, 49 indium, 50 tin, 51 antimony, 52 tellurium, 53 iodine, 54 xenon, 81 thallium, 82 lead, 83 bismuth, 84 polonium, 85 astatine, 86 radon, 113 nihonium, 114 fluoranium, 115 MC, 116 LV, 117 TS, and 118 OG. So these are the atomic number of these elements. General concept which you have to remember is about atomic number is magic number 288, 18, 18, 32. Now atomic radius. Atomic radius increases top to bottom. Increases. Why it increases? In group. Atomic radius increases in group and decreases in period. These are the general trends which you should remember. Means as boron is of second period element and we talk about aluminium, aluminium is third period element. So definitely one energy cell is increasing, so its atomic radius will increase. But some of the exceptions are there in chemistry, as you know very well. Group number 13 elements I am talking, boron's atomic size is less than aluminium. But gallium and aluminium relation if you find, that will be aluminium atomic size is greater than gallium. This thing we have already read in class 11, that why aluminium atomic size is greater than gallium. This is due to poor shielding effect, because you know very well, before gallium 3d orbitals enters and after then 4p1 starts, so that's why there is a poor shielding effect. So the reason of the greater atomic size of aluminium and gallium is poor shielding effect, and then it increases. So top to bottom atomic radius increases and left to right decreases. Left to right decreases because of effective nuclear charge. As the number of protons and electrons increases, effective nuclear charge increases and the atomic radius decreases. So here the first property, that atomic radius increases from top to bottom and decreases left to right or in a period, right? Now after understanding this concept, fourth, ionization enthalpy. Ionization enthalpy. What is ionization enthalpy or ionization energy or ionization potential? The minimum amount of energy required to remove an electron from an isolated gaseous atom is called ionization energy. So if you remove 1 electrons from each of the orbit of p block elements, so you know very well, if we remove here boron's electrons, last electron, so it will be of 2p1, and then next 2s2, then next 2s1. So here as we remove 1 electron from its orbit, it requires more amount of energy. But if we come top to bottom, right, top to bottom, ionization energy decreases in group. Decreases in group. Why decreases? Because atomic radius increases, the attractions of electron towards the nucleus as the atomic radius increases, attraction decreases. So it will be easy to remove an electron in the maximum atomic size. So that's why ionization energy decreases in group and increases in period. But here also there are some exceptions, like you can say here, so the first ionization energy of nitrogen is greater than the first ionization energy of oxygen. The reason behind that is 2p3 and 2p4. This thing already we have studied in chapter number 3, class 11, classifications of elements and their periodic properties. Because it is half filled and it has one more electrons than half filled, so that's why it's easy to remove one electron from group number 16 in comparison to group number 15. So there are some exceptions which we should understand, but these are the general concept. As the atomic radius increases, ionization energy or ionization potential decreases. As the atomic radius decreases, the ionization potential or ionization energy increases. General concept. Exceptions of group number 15 and 16th elements, and sometimes group number 13 and group number 2 elements also. Now after understanding this concept, ionization energy, now let's talk about oxidation state. Do you know oxidation state? What is oxidation state? What is valency? What is valence electron? Variable valency is called oxidation state. What is valency? You have learned the define of valency, right? What is valency? Valency means the combining capacity of an element is called valency. But everywhere it's not combining, somewhere it's losing also. But here after 14th group it combines, and before 14th group it loses. So we can say the define of valency, that valency is the combining capacity of an element, or it is a tendency to acquire octet in its last orbit, either by gaining or losing. That is called valency. So you know here group number 13th elements, they can lose their 3 electrons and they can gain their inert gas configuration. So the valency of group number 13 is 3, 14 4, 15 again 3. Why? Because these elements have 5 valence electrons. So they will take 3 electrons and complete their octet. So here the valency of group number 15 is 3 and the valency of group number 18 is 0. But what about oxidation state? Oxidation state means whatever the number of electrons it can acquire or lose, that complete number of electrons from its outermost orbit is called oxidation state. As for example, if we talk about group number 13, it requires 5 electrons in its outermost orbit, but it can lose all the 3 electrons 1 to 1. So here the oxidation states of group number 13 is +1 and +3. 14th is +4, -4 and +2. 15 is -3, +3 and +5. Group number 16 -2, +2, +4, +6. 17 is -1 and 18 is 0. -1 to +7 it is. So don't forget, because it has total. So oxidation state means to gain or lose electrons from its outer orbit, from its outermost orbit, which is also called valence shell or valence shell. As for example, just suppose I am talking about nitrogen, right? Nitrogen atomic number is 7. Electronic configuration 1s2, 2s2, 2p3. So here it has 2 electrons in S and 3 electrons in 2p, right? So here it requires 3 electrons to complete its octet. So -3, because if we give 3 electrons, so it will get an electronic configuration of 2p6. But if it starts losing its electron, just suppose if it loses all these 3 electrons, so it will get 2s2, which is a stable configuration of second orbit because it is very near to the nucleus. So if it loses all the 3 electrons, then plus 3. It can be plus 1 also, it can be plus 2 also, it can be plus 3 also. But if I talk about here, total oxidation state is minus 3 to plus 5. Why minus 3 to plus 5? Because gaining of electron 1 to 1 it will gain. So minus 3, minus 2, minus 1, 0. If doesn't gain or doesn't lose, then 0. If it gains, then minus 1 to minus 3. And if start losing, then first it will lose 1 electron, then second electron, then third electron, then fourth electron, and then fifth electron. So these are the oxidation states of group number 15 element, in which the most stable oxidation state will be this, 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 and this. Why 0? This is its half filled p orbital. Why this minus 3? It will be full filled of p orbital. Why this plus 3? Full filled of s orbital, 2s, 3s or any s orbital. And why this plus 5? It will gain inert gas configuration. So that's why these are the few stable electronic configurations, oxidation states. So you can understand any elements whose stable electronic configurations, oxidation state are what. So by achieving or losing its electron from its outermost orbit, it gives you the confirmations about what are the stable oxidation states. Already I have written here group number 13, 14, 15, 16, 17 and 18. Sometimes you must remember group number 13 is generally known as boron family, 14 carbon family, 15 nicogens, 16 chalcogens, 17th halogens, and 18 noble gas or inert gas. So these are some few of the physical properties which you should understand about this whole p block elements. Now the most thing which we are going to study in 12th standard is about the group number 15 elements and the compounds formed by group number 15 elements. Group number 15 elements are nitrogen, phosphorus, arsenic, antimony, bismuth. Remember, leave this MC. Nitrogen, phosphorus, arsenic, antimony, bismuth. Right? General electronic configuration: 2s2, 2p3 of nitrogen, 3s2, 3p3 phosphorus, 4s2, 3d10, 4p3, 5s2, 4d10, 5p3, 6s2, 4f14, 5d10, 6p3, and leave this MC is not in use right now. So here you have to remember from nitrogen to bismuth its electronic configuration, oxidation state, and one more thing, the most important thing, sixth property is metallic and non-metallic character. Metallic character increases in group and decreases in period. Remember the word, increases in group and decreases in period. Means last periods are their metals: thallium, lead, bismuth, polonium, strontium, radon. These are the metals, pure metals. So remember, metallic character increases in group and decreases in period. Why I am saying you decreases in period? Because you know very well group number 1 and 2 are alkali and alkaline earth metals. From boron, carbon, nitrogen, oxygen, fluorine, as we move right side we get non-metals. Out of this group number 15 elements, this nitrogen and phosphorus are gas, arsenic and antimony is generally we say noble gas, or you can say these are non-metals. What do you say? Non-metals. This is metalloids and this is metal. So why I have said this? Because I have written here metallic character increases down the group. So you should remember these physical properties. Now we'll discuss about the compounds of nitrogen like dinitrogen, ammonia, nitric acid, nitrous acid, but whatever is in our syllabus, we'll go through that only. You should remember this concept. If you know about this general concept, then you'll be able to start your class 12 group number 15. So this was just a basic of p block elements. In the next video, I'll tell you about the compounds of nitrogen like dinitrogen preparations, properties and uses. Similarly about the ammonia, nitric acid also. That's all for today. Thank you very much. Have a great day. Don't forget to like and subscribe the channel. Thank you very much.